In May of 2015, the engineering firm of Arceneaux, Wilson & Cole completed the longest direct pipe drilling project in North America to date, and only the fourth construction of its kind in the U.S. In order to connect a larger pipeline running from the municipal water plant in Port Arthur, Texas, to the Cheniere LNG facility 17 miles away in Cameron Parish, Louisiana, a 3,500 2-foot section of 48-inch diameter pipe had to be installed underneath a U.S. Army Corps of Engineers hurricane flood protection levee, a railroad switchyard, and the 1,000-foot wide Sabine-Neches Canal, while maintaining a small enough construction site so as not to disturb a residential neighborhood on one side or a heavily trafficked highway on the other. This project presented a number of obstacles, which Arceneaux, Wilson & Cole was able to overcome through a combination of innovation and collaboration. First, it was imperative that the installation of the pipeline not compromise any of the structures on the surface above. The levee, which has held back floodwaters during the region's most devastating hurricanes, is vital to the safety of the people and businesses of Port Arthur. Beyond the levee, the pipeline would run beneath a railroad switchyard, capable of storing up to 500 rail cars at a time, before passing under the nation's third busiest waterway, the Sabine-Neches Canal, an economic lifeline of southeast Texas and the U.S., through which more than 125 million tons of cargo is transported each year. Working with the U.S. Army Corps of Engineers, a soil hydraulic fracture analysis was performed in 2012 to determine if traditional horizontal directional drilling, or HDD, would be safe enough to maintain the integrity of the ground above the pipeline. The soil formation in Port Arthur is mainly a firm clay with some silty clay. Due to the softer nature of the soil, this analysis failed to return a sufficient safety rating for the high pressures involved in traditional HDD. Therefore, a unique drilling method called direct pipe was employed. The direct pipe method does not require high drilling fluid pressures and controls the pressure at the drilling head, thus greatly reducing the risk of hydraulic fracture of the soil formation. The direct pipe system, designed and operated by the German company Connect, allows a pre-welded pipeline, which is laid out behind the launch pit on rollers, to be installed at the same time as the borehole is being excavated. The system consists of a directional micro-tunneling machine welded to the front of the pipeline and a 750 metric ton hydraulic pipe thruster. As the pipe thruster pushes the pipeline, the cutter head breaks up the soil at the tunnel face, where it is mixed with a bentonite lubricant and returned back through slurry lines inside the pipe being installed. The slurry is then pumped back to a separation plant, where the excavated material is removed and hauled away. The slurry lines then carry the bentonite lubricant back to the cutter head to be reused. This fluid is also injected in the annular space around the pipe, reducing the friction created by the drilling. The system is operated from a control center on the surface, where the operator can start and stop the drilling, as well as precisely steer the micro-tunneling machine on the specified profile and alignment. This steering capability was crucial for navigating the 48-inch pipe through a 10-foot passageway at one point, as well as achieving a breakthrough within inches of its intended target. The direct pipe system offers many advantages over traditional HDD. Since the pipeline itself provides permanent support for the borehole, there is no need for expensive shaft construction. Since the pipeline is welded above ground, it can be inspected before insertion, leading to greater safety. Also, very high installation speeds are possible with this method. An average rate of 6 feet per hour, with rates of up to 20 feet per hour, were achieved for this construction. Another advantage of the direct pipe system is the small footprint needed for operation. This was a necessity considering the extremely limited operating space available for the construction. Sandwiched between State Highway 82 on one side and a residential neighborhood on the other, the construction had less than a 120-foot wide right-of-way in which to operate. Even in this confined space, there was ample room for the launch pit, the operator and control center, and the slurry separation plant, while leaving enough room for construction and support vehicles to maneuver easily. The space needed for the prefabricated pipeline or pullback string presented another obstacle. The direct pipe system requires that the pipeline be welded and laid out on rollers behind the launch pit. Achieving a workable space for the pullback string meant closing off highway access to a street located a mere 400 feet behind the launch pit and detouring traffic for the duration of the installation. Because this space was extremely narrow, set between the highway and a drainage canal, one lane of the highway also needed to be closed. With only 2,100 feet of workspace available for the pullback string, an additional 1,400 feet of pipe needed to be welded into the line after drilling had commenced. In order to achieve this, the extra pipe was welded in 400-foot sections beside the pullback string, then moved into place and welded into the line piece by piece before the rest of the pullback string was finally attached. The ability of the direct pipe system to be started and stopped as needed was crucial to this step and allowed for extended pauses in the drilling with no adverse effects. Despite being able to operate in such a constricted space, the project necessarily created some inconveniences for the neighboring residents which had to be addressed. A 2-block section of Foley Avenue, which included driveway and parking access for a few homes, had to be shut off. To accommodate these residents, new driveways and carports were constructed. Noise was also an issue. City ordinances allowed for specific noise levels for various times of the day. Based on several recordings made at the construction site, AWC decided to erect a sound dampening wall, 15 feet high and 900 feet long, in order to shield the community from the majority of the construction activity noise. After 29 days of 24-hour, 7 days per week operations, breakthrough was achieved in a public park on the other side of the canal. The precision of the drilling allowed for a very small reception pit to be dug the day of the breakthrough, minimizing any disruption to visitors' access of the park. Once the micro-tunneling machine was disconnected from the head of the pipeline, all the internal lines and support were removed from inside the pipe, and the thruster was disassembled and removed, the actual carrier pipe could be installed. The relatively simple process of installing this 30-inch high-density polyethylene or HDPE pipe consisted of fusing the sections into 1,600-foot strings, again laid out on rollers behind the launch pit, then pulling the strings through the steel casing pipeline from the reception pit. All that remained was to restore the construction site to its original state. Within 21 days, all signs of construction were removed, leaving no evidence that the longest pipeline installation of its kind in North America had just been achieved. The entire project, from approval to final site cleanup, was accomplished in less than 5 months, well under the 180 days stipulated in AWC's contract. With expert knowledge and understanding, detailed analysis and planning, and by utilizing the most advanced technology and assembling the most capable team, Arceneaux, Wilson & Cole were able to quickly and flawlessly execute a world-class engineering feat, years in the making.